Okay, so we've already taken a look at how to graph hyperbolas, but they weren't translated yet. Today we're going to talk about what happens when we move the center. So that's what you see here with the x minus 2 and the y plus 4 now. We didn't have that before. We just had, x squared and y squared. But now we have this 2 and this 4 here, which is going to move to our center. So what I want to do first is come over here and write the formula down in standard form. So what I mean by that is I'm going to write x minus 2 squared over, fix that, 4 squared minus y plus 4 squared over 1 squared equals 1. Now from here we can take out the center. This is similar to the drill in the first day of this unit where the center was just the opposite of these numbers in the parentheses. So our center is going to be positive 2 and negative 4. So I'm going to note that over here. That's actually one of the things I'm asking for in this problem anyways. Okay, so we have one of the things done. So what I'm going to do is I'm going to put that on the graph over 2 and down 4. Okay. Now, this is really important. What I'm going to do now, I'm going to change the color so I can highlight this number right here. This is how we're going to determine what our vertices are. So, I'm going to write V. I'm going to leave a spot for both my vertices because as we've talked about before, we're going to have 2 of them. I'm going to take this number here, 4, and I'm going to use that again to get my vertices. I know that this is a horizontal hyperbola, meaning that it opens left and right, like this. So since it's one that opens left or right, I'm going to use this first number, and I'm going to go that amount left and right from the center point. So again, I'm going to use this number here. Since I know it opens left and right, I'm going to go here to my center point and go 1, 2, 3, 4. Here's my one vertice. I'm going to also go 1, 2, 3, 4 to the left. Here's my other vertice. Very similar to before, in order to make our box, we need to also use this b value here. So this box, again, really isn't part of our graphs. I'm going to change the color again. But again, what we did last week was we went over 4 and up 1. We also went over 4 and down 1. We did this in every single direction. Over 4, up 1. Over 4 again, and down 1. This gives us our box. When we talked about we can connect the box if we'd like to, but really what's important is that we get these diagonals in there. Again, that's going to be our guidelines for how fat or skinny, for lack of a better phrase, our hyperbola is. I guess I'll go with green. We can go ahead and sketch the hyperbola now. You can also write in what my vertices are simply just by identifying the points on the graph. 6, negative 4. The other point over here is negative 2 and negative 4. You'll notice that the y values here are exactly the same. So last week, or before when we did these hyperbolas, these were both like 0 and 0, but since we've shifted it a little bit, these are all still going to be the same, but instead of 0, 0, they're going to be negative 4 and negative 4. So let's figure out the other couple of things. So we've taken care of a bunch of things here so far. We've taken care of the vertices. We've also taken care of graphing the function. We still need to figure out what the the focus points are, or the foci, or some of you guys like to call it the foci. So just like before, there's going to be 2 focus points. We're going to get these focus points by doing something very similar to before, but instead of just getting that C value using the Pythagorean theorem or A and B, we're going to get the C value, but then we're going to count that from the center in both the right and the left direction. So let's first figure out what the C value is. Again, the C value is found by doing the Pythagorean theorem, 4 squared plus 1 squared equals C squared. And I know you guys know how to solve this. When you solve this, you'll get C is equal to the square root of 17, which is approximately 4.1. I'm going to use this number here, and again, I'm going to count over 4.1 units from the center of the graph. So 1, 2, 3, 4.1 is going to be about right here. I'm going to also go in the left direction. 1, 2, 3, 4.1, so somewhere in here. So there's our 2 focus points. Again, the focus always lies within our hyperbola or within our parabolas. Okay. So you can kind of just simply think about this and, okay, what would the focus points be? Well, I went a little bit further, that 0.1 further. So this is going to be 6.1 and negative 4. This is going to be negative 2.1 and negative 4. Last but not least, we still have to do the domain and range. So I'll put that up here. The domain of this, since we're going to go all the way from negative 2 all the way to negative infinity, we'll first start off with negative infinity to negative 2. Just like before, we're going to union that with the other set of the domain. So if we're starting at positive 6, and we're going all the way to infinity. Our range, possible y values, is going to be negative infinity to positive infinity. Okay, so now we've done everything the question has asked us to do.